Let's continue with number 19. We're going to use the figure above to answer both 19 and 20. 19 reads, name an angle that is not adjacent and not vertical to angle STP. So let's highlight that angle STP. So we need to not be adjacent. Again, the word adjacent means next to. So that would eliminate STW and PTQ as adjacent, the ones that are most easily identifiable as adjacent. There are others. Next, we don't want to be vertical. Again, vertical angles form an X and only share a vertex. So the vertical angle is RTQ. So we're going to get rid of this one because we do not want to be vertical. So by process of elimination, an easy one to say is WTR. They don't share a wall and they don't form an X when they're connected, as you can see in my highlighting, which is not the greatest, but that's not a perfect X. So angle WTR. There are others out there though. Number 20 would like for us to find the value of X. So both STW involve X and WTR. And together, those two make up STR, which is a 90-degree angle. So for number 20, we're going to do angle plus angle equals 90. So that's the measure of angle STW plus the measure of angle WTR is equal to 90. I'm going to change screens so I have more space. Oh, dang it, I need the picture. So we have 2x plus 5x plus 6 equal to 90. Now let's solve for x. Combine 2x with 5x, you're going to get 7x plus 6 equals 90. Subtract 6 on both sides, you would get 7x is equal to 84. And divide by 7 on both sides, you would get x is equivalent to let me grab my handy dandy calculator because it's not coming to me off the top of my head. I can't think of multiples of 7 that have a 4 on the end. 12. Yep, 14 too. Yep, makes sense. So x is equivalent to 12. On number 27 is where we'll go next before I scroll down. It says draw and label a picture of the following situation. Line C bisects segment AB at point W. So we have a segment AB. I'm going to cheat and use my line tools. So this is going to represent segment AB. We need a point W. And then we need another line bisecting. Bisect me is more than intersect. It's a lot more powerful than that. Bisect means that it splits the segment into two congruent parts. So A to W is congruent with W to B. So that means W is your midpoint. That's how crucial that word bisect means. It doesn't just cross it, it crosses at the midpoint. So again, bisect means cross at the midpoint, cut it into two equal parts. So now let's label based on the given information. It says AW is 3x plus 8. So from here to here. Then it says WB is 5x minus 4. It wants us to find AB. We're going to find the length of AB. When it says AB, it wants us to find the value whenever it doesn't have the bar at the top. So we know that W again is our midpoint. So we can set it up as part equals part. So we can solve for x. So what that means in geometric terms is AW is equivalent to WB. Again, yes, show your geometric equation. And now we substitute the expressions. 3x plus 8 is equivalent to 5x minus 4. And now we solve for x. First thing I would do, subtract 3x on both sides. So you have 8 equals 2x minus 4. Add 4 to both sides. You would have 12 equals 2x. And divide by 2. So 6 is equal to x. Again, read your instructions. I'm not done because it wants me to find AB. So there are several ways to find AB. The simplest way that I can think of is, since I know that these are equivalent, instead of writing them twice or adding both of these together, I'm going to say 2 times one of them. But does not make sense to you? Because where they're equivalent, they're congruent, can I just double one of them and get my result? Yes, I can. So if I distribute my 2, I would have 6x plus 16. And now if I replace x with 6, so that'd be 6 times 6 plus 16. 6 times 6 is 36, plus 16 is 52. So AB has a length of 52 units. Let's look at number 28. In the figure below, ray or line, I can't see it right now, or segment BR bisects angle ABC. So there's that word bisect again. So again, bisect means cut in two equal parts. So angle ABR, this angle up here, is congruent to angle RBC, this angle down here. So when we show congruent angles, we put a little arch in the corner where the vertex is. Sometimes you also see it with a arch and a tally. It just depends. But usually, most commonly, it's just the arch on its own. Then it goes to tell us that ABR, ABR is 4x plus 5. It also mentions that ABC is 46. So this entire angle is 46 degrees. It wants us to find the value of x. There are several ways to attack this problem. One way is to, if you know the entire angle is 46, then each little angle has to be the same measure. So that means each little angle has to be 23. So this has to equal 23, and this has to be 23 for the grand total to be 46 and for them to be congruent. So knowing that, I can say 4x plus 5 is equivalent to 23 to solve for x. Then subtract 5, you would have 4x is equal to 18. Then divide by 4, x is equal to 18 fourths. Both of them are even, so that's 9 halves. So about 4.5 as well, if you wanted to change it to a decimal. Again, there's another way you could have attacked that problem. That's just one way. Now let me zoom out a smidge to be able to answer 21 through 26. I need to use that picture for all of those questions. 21 asks about x, v, y. X, v, y. It's asking if it appears to be acute or obtuse. Acute, again, is less than 90. Obtuse is greater than 90. So a 90-degree angle makes a perfect L. So if I were to take another sheet of paper and try and fit it into the vertex, the corner piece is a perfect L, so it's a right angle, and it appears to be acute, less than that. Number 22 wants us to name an angle that is vertical to YVZ. So YVZ is this angle here. So what angle would make a perfect X with that angle right there? What angle is only sharing a vertex? So that's the only thing they have in common. The angle would be WVU. Again, together they form a perfect X or a bow tie. So angle WVU. And again, when it comes to naming angles, the order of the lettering doesn't matter as long as the vertex is in the middle. For 23, it wants us to name an angle that is supplementary to WVX. Supplementary means that it adds to 180 degrees. So that means together they should form a perfect line. So WVX is our first one. So on this instance, I see a perfect line when it is joined together with XVZ. That's a perfect line. So that's an option. And I believe that is our only option for that angle. So angle XVZ. Sorry for the interruption. 24 wants us to name an angle that forms a linear pair with angle WVU. So a linear pair has to have two criteria met. First, they have to be adjacent and they have to be supplementary or form a line. So let's look at WVU, which is here. So on this one, it's adjacent and forms a line with UVZ. So we would say angle UVZ. Or if you look at another set, we could say WVY. So angle WVY. Either or, you don't have to write both. But both of those are acceptable in this situation. 25. If the measure of angle WVY, this angle here, measures 130, it wants to know what is the measure of WVU. WVU. We just got done discussing that they form a linear pair. So this is a scenario of angle plus angle equals 180 degrees. So the measure of WVU plus the measure of angle WVY is 180. So the measure of WVU plus 130 is 180. So when I subtract 130, the measure of angle WVU is equivalent to 50 degrees. So again, show your geometric equations, folks. I need to see the angles by name and then substitute in the appropriate location and then calculate. Yes, it seems like a lot, but I am expecting to see it, please. Again, there's always methods to my madness. Number 26 says WVU, this angle here, is 35 degrees. And then it mentions YVZ is 5x plus 10. Those two angles together form a perfect X. So that means they are vertical. So this is the part where we'll do angle equals angle. So the measure of angle WVU is equivalent to the measure of angle YVZ. Now that's the geometric equation, sub in the expressions. So, excuse me. 35 is equivalent to 5x plus 10. Let's solve for x by first subtracting 10. Gives you 25 equals 5x. Then divide by 5. So 5 is equal to x. On to number 29. In the figure above, what is the angle pair name for angle 3 and angle 5? So they share a wall, so they are adjacent. They form a line, so they are linear pair. And because they're a linear pair, their measures are together equivalent to 180, so they are also supplementary. Number 30 says, what is the angle pair name for angle 3 and angle 2? So angle 3 and angle 2 together make a perfect X, only touching at the vertex, so those are vertical. We don't have any measurements at the time to determine if they're complementary or supplementary, so vertical is the only thing we know for sure. 31. If B is the midpoint of AC, find the coordinates of C. So we're not going to use the midpoint formula on this question. We're already provided with the midpoint, that's B. We need to use that information to find C. So this is when we use our EME method. So again, I'm on this question. EME, endpoint, midpoint, endpoint. So our endpoints are A and C. Our midpoint is B. Currently, A is at 610. B is at 1425. So we have to establish the pattern between the x's and the y's to determine what is happening in this scenario. So on my x's, I went from 6 to 14. So that's an increase by 8. So if the pattern continues and I add 8 more to 14, I would be at 22. Over here on my y's, I go from 10 to 25, so that's an increase by 15. So if I continue to increase by 15, I would end up at 40. So point C has the coordinates 22, 40. And last but not least, number 32. Find the ordered pair that is 3/4 of the distance from A to B. Now we have to use our fractional distance notes for the coordinate grid, and that's when we had to do a total of 6 steps. We had to find a new x and a new y. So to find the new x, we first find the total distance of all of our x's. So that's x sub 2 minus x sub 1, the absolute value of that. So again, you should always start with the larger x. So that would be 14. And the smaller one is 6. So the total distance is the absolute value of 8, which is just 8. Once you have that total distance, you take the total distance, which is 8. This is a 2. So step 2. Take the total distance and multiply it with the provided fraction, which is 3/4. So put 8 over 1 and multiply. So you're going to get 24 over 4, which is 6. That's your fractional distance. The next thing you do is establish where you're starting. And I'm moving from A to B. So I'm starting at A. So I'm taking A's x value. And since I'm moving to the right, because my x's are getting larger, I'm going to add my fractional distance, which is 6. So A's x value was 6. 6 plus 6 is 12. So the new x value is 12. Now let's find our new y. So we repeat the same steps just for y. So again, first find the total distance in my y. So y sub 2, the absolute value of y sub 2 minus y sub 1. Again, always start with the largest one. So the largest one is 25. The smallest is 10. So that's the absolute value of 15, which is 15. Then again, you take the total distance, 15, times the provided fraction, 3/4, to get your fractional distance. So that's going to give me 45 over 4. And that cannot reduce. Did I do that right? 25 minus 10 is 15. And then 15 times 3/4. 15 times 3 is 45 divided by 4. Oh gosh, no. It'll be 11.25. Yeah. So it doesn't reduce, so it's 45/4 or 11.25. Now you take your starting y value. So since I started at A, I take A's y value. And my y's are increasing, so I'm going to add my fractional distance, which was 11.25. So the original A value, or sorry, Y value was 10 plus 11.25 is going to give me 21.25 as my new Y value. So as a complete ordered pair, we would write 12 comma 21.25. And this concludes the tutorial.